Okay, so this is day 10 of AMI, and this is the only AMI day where you should have been using a calculator. This is a BC specific question, and it was question number 2, the year it was tested. So for part A, we are trying to find the position of the particle. So for position, we're dealing with parametric equations, so we need to have an x coordinate and a y coordinate. They've given us dx dt, and then they've given us y of t. So the y coordinate is going to be really easy. The x coordinate, though, since we're given dx dt to find x, that means we're going to have to integrate. So if we want x of 3, they've given us this initial condition. At t equals 0, the particle is at 5, 1. So that means we know what x of 0 is. So that means the boundaries for our integral are going to be 0 and 3, and then we're going to have x prime of t, or dx dt. It's the same thing. Since we know 0 and we're trying to find 3, that means we are moving in the positive direction, so we are going to add that integral. So since this is a calculator question, that's really all they need to see. And then you can plug that in the calculator, and that gives you 14.377. Now y of 3 is a whole lot easier because this is your y graph. So y of 3 is right there, is negative 1/2. So if we want the position at t equals 3, our x coordinate is 14.377. Our y coordinate is negative 1/2. Now for B, we want the slope of the tangent line to the path of the particle at t equals 3. So that means we want dy dx at t equals 3. So that means we want dy dt at t equals 3 over dx dt at t equals 3. Now we have the dx dt equation. So that means we are going to do 3 squared plus sine of 3 times 3 squared on bottom. Now on top, the dy dt, we want the derivative of y at 3, which really means we want that slope. So we want up 1 over 2, so that slope is 1/2. And so now that is a matter of, again, just plug it in your calculator, and that is going to come out to 0.05. So that's your A and your B. Part C, we are trying to find the speed of the particle. So speed is one of those equations that we talked about like right before we were out of school. So the speed equation is x prime, and we want it at 3 squared plus y prime of 3 squared. That's all that they need to see, and you can plug it in your calculator. I should not have put that square root there. So the speed is equal to 9.969. They would also accept 9.968 because they don't care if you round or if you truncate. Now part D, we want the total distance traveled by the particle from 0 to 2. So total distance traveled looks like the speed equation, but it has this integral in front of it. So 0 to 2, square root of x prime of t squared plus y prime of t squared dt. Our only issue we're going to have is if we look at this from 0 to 2, y prime from 0 to 1 is the slope of that line, which is negative 2. But y prime from 1 to 2 is 0. So we're going to end up having to write 2 integrals for this. So we're going to integrate from 0 to 1. The square root of x prime is defined, so we don't actually have to rewrite that. But for 0 to 1, we are using negative 2 for your y prime. Then we're going to add the integral from 1 to 2. X prime is defined. We don't have to write that one out. And then y prime is 0. So that's what they're looking to see. And then you just plug into your calculator and you get 4.350. They would also accept 4.349. It doesn't matter which one you pick. So that is our last day of AMI. So we will be looking at starting AP review after this.